In the vast expanse of the cosmos, amidst billions of galaxies and countless stars, a profound question echoes. Are we alone? If the universe is teeming with potential life, why haven't we encountered any other intelligent civilizations? Are we truly unique, or are there other beings out there searching for answers just like us? Is there a great filter that prevents civilizations from reaching the stars? And if so, have we already passed it, or does it lie ahead in our future? What would contact with an extraterrestrial civilization mean for humanity? Join us as we delve into the Fermi Paradox, exploring the possibilities of life beyond Earth and searching for clues to answer the ultimate question: are we alone in the universe? The Fermi Paradox, named after physicist Enrico Fermi, is a philosophical and scientific puzzle that has been debated for decades. It questions the apparent contradiction between the high probability of the existence of extraterrestrial civilizations and our lack of evidence for or contact with such civilizations. The paradox is often framed as a question: where is everybody? Or why haven't we seen any signs of intelligent life elsewhere in the universe? This begs the question: why haven't we encountered any aliens yet, despite the vastness of the cosmos and the potential for life to exist on other planets? The Fermi Paradox is significant in the search for extraterrestrial life because it highlights the apparent discrepancy between the likelihood of life existing elsewhere in the universe and our failure to detect it. This paradox has sparked intense scientific and philosophical discussions, with various theories and hypotheses being proposed to explain the silence. One of the most intriguing aspects of the Fermi Paradox is the possibility that advanced civilizations may be avoiding contact with us, either intentionally or unintentionally. This idea is often linked to the concept of the Great Filter, which suggests that there is a barrier or filter that prevents civilizations from becoming interstellar, and that we have not yet passed this filter. The Fermi Paradox has also led to the development of new areas of research, such as the search for extraterrestrial intelligence and the study of the conditions necessary for life to emerge and evolve on other planets. The paradox has also inspired scientific fiction and has been a topic of discussion in popular culture, as seen in movies and books like Contact and The Elegance of the Hedgehog. The Fermi Paradox is a concept that questions the apparent contradiction between the high probability of the existence of extraterrestrial civilizations in the universe and the lack of evidence or contact with such civilizations. It is named after physicist Enrico Fermi, although he did not formally propose the paradox. The core question associated with the Fermi Paradox is: where is everybody? This question reflects the puzzling silence in the universe, considering the vast number of potentially habitable planets and the high likelihood of intelligent life evolving elsewhere. The origin of the Fermi Paradox can be traced back to a lunch conversation in 1950 between Enrico Fermi and his colleagues Edward Teller, Hilbert York, and Emil Konopinski. During this discussion, Fermi posed the question: where is everybody? This question highlighted the discrepancy between the high probability of extraterrestrial civilizations existing in the vast universe and the absence of any conclusive evidence or contact with such civilizations. The paradox essentially arises from the assumption that given the immense number of stars and planets in the universe, the probability of intelligent life evolving on other planets is high. However, despite this probability, we have not observed any definitive signs of extraterrestrial civilizations. This discrepancy between the high likelihood of extraterrestrial life and the absence of observable evidence raises profound questions about the nature of intelligent life, the challenges of interstellar travel, and the limitations of our current scientific methods in detecting alien civilizations. It also leads us to ponder: is there a great filter that inhibits civilizations from expanding and reaching out to the stars? Enrico Fermi's simple query led to the popularization of the Fermi Paradox, which is often attributed to Michael Hart. Hart's argument suggested that the absence of observable extraterrestrial civilizations implied their non-existence, as interstellar travel and colonization should have been inevitable if intelligent life existed elsewhere. This perspective laid the foundation for the Fermi Paradox as we know it today, prompting us to ask: is the absence of evidence truly evidence of absence, or are we simply not looking in the right places or using the right methods? The impact of Fermi's question and the subsequent exploration of the paradox have been profound in the scientific community. It has spurred extensive research, debates, and various theories attempting to explain the silence of the cosmos. Scientists have delved into topics like galactic exploration, self-replicating probes, nodes of information exchange, and alternative solutions to the paradox. aiming to unravel the mystery of the missing extraterrestrial civilizations. The Fermi Paradox, which questions the apparent absence of extraterrestrial civilizations despite the high probability of their existence, has been addressed by various solutions. These solutions attempt to answer the question, why haven't we heard from aliens, and can be broadly categorized into three main groups: those that deny the existence of extraterrestrial life, those that offer alternative reasons to explain the non-occurrence of a first contact, and those that assume the existence of extraterrestrial life but propose alternative explanations for the lack of contact. Denial of extraterrestrial life. One solution to the Fermi paradox is to assume that Earth is unique in having life. This perspective suggests that the conditions that allowed life to emerge on Earth are so rare in the universe that intelligent life is unlikely to exist elsewhere. This solution implies that the probability of intelligent life existing elsewhere is very low, making it unlikely that we will ever encounter extraterrestrial civilizations. Limitations on interstellar travel. Another solution proposes that interstellar travel is either impossible or too difficult for civilizations to expand beyond their home planet. This could be due to various reasons, such as the distances between stars being too great, the cost of interstellar travel being prohibitive, or the civilizations naturally declining or eliminating themselves before interstellar travel becomes possible. Self-destruction of intelligent civilizations. A third solution suggests that advanced civilizations do arise, but they rapidly disappear due to their self-destructive tendencies. This could be due to various factors such as war, environmental degradation, or the misuse of advanced technologies. Different forms of alien life. Some solutions propose that intelligent life may exist in forms that are hard to detect, such as in subsurface oceans or in the atmospheres of other planets. This could mean that we are not looking for life in the right places, or that our methods for detecting life are not sophisticated enough. Aliens deliberately avoiding contact. Another solution suggests that advanced civilizations may be deliberately avoiding contact with us until we are ready to communicate with them. This could be due to various reasons, such as not wanting to interfere with our development or not wanting to be detected. Life existing in subsurface oceans. Some solutions propose that life may exist in subsurface oceans, which could be a more hospitable environment for life than the surface of a planet. This could mean that life is more common in the universe than we think, but it is not detectable by our current methods. The Drake equation. The Drake equation is a mathematical formula used to estimate the number of intelligent civilizations in the galaxy that might be able to communicate with us. The equation takes into account various factors such as the number of stars with planets, the number of planets that can potentially support life, and the number of civilizations that develop intelligence. The equation suggests that there could be thousands of intelligent civilizations in the galaxy, but we have not yet detected any. The Fermi paradox remains an open question, and the solutions proposed so far are not mutually exclusive. It is possible that the truth lies in a combination of these solutions. The search for extraterrestrial intelligence continues, and the discovery of even a single extraterrestrial civilization would greatly advance our understanding of the universe and our place within it. The Fermi Paradox, which questions the apparent absence of extraterrestrial civilizations despite the high probability of their existence, remains an open question in the scientific community. Ongoing efforts to solve the paradox involve advancements in telescopes and space missions, as well as the search for habitable exoplanets. Advancements in telescopes and space missions. The James Webb Space Telescope is a significant step forward in the search for extraterrestrial life. With its ability to observe in the infrared, it can detect the heat signatures of distant planets, potentially indicating the presence of life. The James Webb is designed to study the formation of the first stars and galaxies, which could provide insights into the origins of life in the universe. Search for habitable exoplanets. The search for habitable exoplanets is another crucial aspect of the Fermi paradox. The discovery of exoplanets that are similar in size and temperature to Earth, such as Kepler 452b, raises the possibility that life could exist elsewhere in the universe. The upcoming Transiting Exoplanet Survey satellite and the James Webb Space Telescope will continue to expand our understanding of exoplanet populations and potentially identify habitable worlds. The need for more data. Despite these advancements, the Fermi paradox remains unsolved. The need for more data and the development of new technologies to detect life beyond Earth is crucial. The search for extraterrestrial extraterrestrial intelligence continues, with efforts such as the Breakthrough Listen initiative aiming to detect signs of intelligent life in the universe. The Fermi Paradox is a complex and multifaceted question that requires continued scientific inquiry and technological advancements. The search for extraterrestrial life and the understanding of the conditions necessary for life to emerge are crucial steps towards solving the paradox. The ongoing efforts to explore the universe and the development of new technologies will ultimately help us understand whether we are alone in the universe. The question of whether we are alone in the universe remains one of the most profound and intriguing mysteries of our time. As we continue to explore the vast expanse of space, we are reminded of the Fermi Paradox, which asks, where is everybody? This leads us to question, is there something inherently unique about Earth that has allowed life to flourish here? Or are we simply a young civilization, yet to make contact with others in the galactic neighborhood? Despite the lack of definitive evidence, the search for extraterrestrial intelligence and the exploration of our solar system and beyond continue to captivate our imagination and inspire new discoveries. Ongoing missions. NASA's Perseverance rover, launched in July 2020, is one of the most significant missions in the search for life beyond Earth. Equipped with advanced instruments, including the SuperCam, which features a microphone to record sounds on Mars, the rover is designed to assess the geology and past habitability of the Martian surface. The Perseverance rover is part of NASA's Mars 2020 mission, which aims to identify and catch samples with a high likelihood of preserving biosignatures in preparation for a future sample return mission. The search for life beyond Earth. The search for life beyond Earth is a multifaceted endeavor involving the exploration of our solar system, the search for exoplanets, and the study of the conditions necessary for life to emerge. The discovery of exoplanets, such as Kepler 452b, which is similar in size and temperature to Earth, raises the possibility that life could exist elsewhere in the universe. The search for life beyond Earth is not limited to the search for intelligent life but also includes the search for microbial life, which could be present in various forms, such as in the subsurface oceans of moons like Europa or Enceladus. The Fermi Paradox, with its perplexing question of where is everybody, has led us on a journey through the vastness of the universe and the possibilities of life beyond Earth. We've explored potential explanations for the silence, from the limitations of interstellar travel and the self-destructive tendencies of civilizations to the possibility of life existing in forms we haven't yet imagined. While the paradox remains unsolved, the search for answers continues to drive scientific exploration and ignite our imaginations. Advancements in technology, like the James Webb Space Telescope, and ongoing missions like the Perseverance rover, bring us closer to understanding the conditions for life and potentially finding evidence of its existence beyond our planet. The Fermi Paradox is not just a scientific puzzle, it's a philosophical inquiry that challenges us to contemplate our place in the universe and the potential for other intelligent beings sharing this vast cosmos. So, what do you think? Are we alone, or are there others out there waiting to be discovered? Share your thoughts and join the ongoing conversation about the Fermi Paradox and the search for extraterrestrial life. The universe is full of mysteries, and perhaps, together, we can unravel them.